Hi dear students, so in the previous class we have discussed about the laws of motion part 2 and now today we'll do some numericals from laws of motion. Okay, so exercise numericals of exercise 3C from concise physics class 9. So I just want to do little bit of difficult numericals which is little bit of difficult for you, but I think all the numericals are very easy. You can do it by your own. Okay, my suggestion, try for yourselves, and if there is any problem then I'll help you. So the equation we're gonna use here, so we have learned a new equation, that is force equals to mass into acceleration. Okay, that is the equation is measurement of force which has come from Newton's second law of motion. Apart from this, V equals to U plus AT, S equals to UT plus half AT square, and V square equals to U square plus 2AS. That is for the case of accelerated motion, and for retardation V equals to U minus AT, S equals to UT minus half AT square, and V square equals to U square minus 2AS. That is for retarding motion. Okay. So this equation we have to use here. So now we'll start from numerical 7. Though the numerical 7 is very easy, but as per my experience I have seen many people have done mistake for doing this numerical. So what is told here? It is told a force acts for 10 seconds on a stationary body of mass 100 kg. So if I am talking about this is a mass, it's a body whose mass is 100 kg. The force is applied on it for 10 seconds. Okay, the force is applied on it. When the force is applied, we have seen there is no motion, and it is told after which the force ceases to act. The body moves to a distance of 100 meters in next 5 seconds. So when for 10 seconds the force is applied on the body, that time the body is not displaced. It is displaced when the force ceases off, then it moves 100 meter after 5 seconds. Okay, so mass M equals to 100 kg, displacement S equals to 100 meter, and time for T1, how much time force is applied, that is equals to 10 seconds, and T2 it is equals to 5 seconds. Simple thing. First question, calculate the velocity. So when it is talking about velocity, you will think about that this type of equations are there, we will follow which equation, but here you see, here it is only told if I follow the last line, the body moves through a distance of 100 meter in next 5 seconds. That means a body moves 100 meter in 5 seconds. So when it is told to find velocity, we know velocity equals to displacement by time. So here no force, no acceleration, nothing is told, only the body is displaced by 100 meter for a time being 5 seconds. So here the velocity will be 100 by 5. It is 20 meter per second. Very easy. Okay. Now next question. The acceleration produced by the force. Acceleration produced by the force. Let's see, when the force is applied on a body, that time, what is the initial velocity? When the force is applied, we have seen initial velocity u equals to 0 because it is already told the body is in stationary condition. Okay, so as the body is in stationary condition, so we can say the initial velocity is 0. Now the displacement, it is told 100 meter after the force applied. Okay, so here we have to see, we have to follow the equation S equals to UT plus half A T square. Okay, so now put the value S equals to 100. What is the value of U here? 0. Time. Which time we have to take? 5 seconds or 10 seconds? See, the force is applied for 10 seconds. And here we are talking about the acceleration due to the force. So how much time the force is applied, that time we have to take 10 plus half of A into 10 square. Okay, so this will be 0. Now if 2 is multiplied here, so A into 100 is equals to 200. 100 square 10 square means 100, and 2 is multiplied with it, it is 200. So A equals to 200 by 100. It is 2 meter per second square. So this is your acceleration due to the force. It is 2 meter per second square. And number 3, what is the next thing is asked here? Next thing is asked, the magnitude of force. We know force F equals to mass into acceleration. So what should be the mass? It is given 100 kg. What is the acceleration? We have seen it is 2. So 200 Newton. So this is question number 7. As if I am talking about the numerical, it is a easy numerical, but the way it is written here, it is little bit of confusing for you. Okay, so copy it. So in numerical number 8, we have drawn a diagram. If you see your book, the diagram is given to your book also, and here it is told in the question that if the mass M equals to 100 gram is moving in a straight line, the straight line is shown here, calculate the force acting on the particle. Calculate the force acting on the particle. So simple thing, we know that force equals to mass into acceleration. Now the question is that mass is given to us, acceleration is not given. Instead of acceleration, what is given? The one graph, velocity time graph. So we know that, we know slope of velocity time graph gives us acceleration. So we have to find the slope of the graph. How we can able to find the slope? First of all, what is a slope? Slope is the angle made by the graph with time axis or x-axis. So this is x-axis, it is y-axis. The slope is an angle which is made by the x-axis. Now the question has come, how can we able to find the slope? So let's take this point A, it is B. So you see, triangle OAB is a right angle triangle. So as it is a right angle triangle, we can able to find tan theta is equals to perpendicular, that is AB by base OB. AB by OB. Okay. If theta is small, okay, if theta is small, then tan theta nearly equals to theta. Okay, that we have already learned in motion chapter. Okay, so you have to remember this thing. Later you will understand that why this thing is occurred. So now whatever the things I have written, you have to remember. So slope theta equals to AB by OB. What is the value of AB? This height. So it is clear, it is 20. What is the value of OB? So OB is 5. It is also given. So it is 4. Okay. So slope is 4. That means acceleration A is 4 meter per second square. Because we know slope equals to acceleration. Now you have to come, that is force equals to mass into acceleration. Now you see mass is given in gram. If I convert it into kg, so it is 0.1 kg. So force equals to mass into acceleration means 0.1 into 4. So 0.4 Newton. That is your answer. Simple thing. Okay, 0.4 Newton. That is your answer. Okay. Now we'll go for next numerical. So if you are having any doubt, just pause the video here, see it again. Okay, if you are having any doubt, then ask me. Next we'll go for which questions? Let's see, I think question number 12. Question number 12 is very important numerical. If you understand question number 12, then I think no other numerical will make any problem with you. Okay, so after 8, we'll go for question number 12. What is given? A bullet of mass 50 grams. See how we have done the numerical. We will just try to write first. Given mass equals to 50 gram. Okay, so rest of the thing it is given in SI. It is given only gram. So we can write 50 into 10 to the power minus 3 kg. That we will make sure earlier. Next, the velocity is moving with an initial velocity 100 meter per second. So initial velocity we have denoted by u. So u equals to 100 meter per second. Okay. Strikes a wooden block and comes to rest after penetrating a distance 2 centimeter in it. So simply, if I am talking about a wooden block, okay, so you can take a wooden block like this also. Just like this. So bullet has come, it is moving inside for 2 centimeter and then it stopped. So 2 centimeter, it is the covered distance inside the block. So S we can write 2 centimeter. S is equals to 2 centimeter. So 2 centimeter, if I convert it into meter, so it is 0.02 meter. Now we will go for questions. Calculate the initial momentum of the bullet. Okay, so before initial momentum we have to see the final velocity. As it comes to rest, the final velocity is 0. So number 1, initial momentum. So initial momentum is equals to m into u, mass into initial velocity. So mass is how much? 50 into 10 to the power minus 3. U equals to 100 multiply 1000 10 to the power minus 3. So it is 5 kg meter per second. That is our initial momentum, 5 kg meter per second. Now we'll go for number 2, final momentum. What is the value of final momentum? So final momentum is equals to m into v, right? Final momentum is asked m into v. So mass is same, 50 into 10 to the power minus 3, but v is 0. So final momentum is also 0. Final momentum is also 0. Next question. Retardation caused by the wooden block and resistive force. So retardation. Retardation means what? A. The value of A you have to find out. So how we have to find A? We are having V, we are having S, we are having U. We don't think about M. So we can use one equation, that is V squared is equals to U squared minus 2AS. Now you may ask, sir, why it is minus? Simple thing, it is a retarding motion. Retarding motion means the acceleration should be negative because the velocity is decreased, and that's why it is minus. If we put the value, V square means 0, U square means 100 square minus 2 into A into 0.02. Okay, so multiply it and let's see. So A equals to 100 square by 0.02 into 2, so that is 0.04. Clear? Now let's see the value. So 100 square means 10 to the power 4. 0.04 means 4 into 10 to the power minus 2. If 10 to the power minus 2 comes up, it will be 10 to the power plus 2, means 100. So 100 by 4, that is equals to 25. So 25 into 10 to the power 4 meter per second square. So 25 into 10 to the power 4 meter per second square. So in your book it is given 2.5 into 10 to the power 5. Same thing is there. Now the question is number 4. Find the force applied. So again we have to come for force. Force equals to what? Mass into acceleration. So it can be acceleration as it is giving retardation. So here A is the retardation and that force should be retarding force. So it should be retarding force. So what is the value of retarding force here? Mass into acceleration. So mass is 50 into 10 to the power minus 3 into 25 into 10 to the power 4. So minus 3 plus 4. So only 10 is there, and 25 into 25 it is 125. 10 for this reason, and here 10. So 12500 Newton. Yes, 12500 Newton. So that is numerical number 12. That is numerical number 12. Now we'll go for numerical number 13. Okay, last numerical seems to be harder, so I will just prefer to do the last numericals. But if you ask me the truth, all the numericals are very easy. Very easy numericals are there. Okay, so same thing, if you are having any doubt, I have just removed the equations also. No problem, I think equation is there in your mind. If it is not there also, I think there shouldn't be any problem. Question number 13. A force causes an acceleration of 10 meter per second square. So acceleration is given 10 meter per second square. Okay. In a body of mass 500 gram. So mass equals to 500 gram. So 500 gram means it is clear, that is 0.5 kg. Okay. Now the question is, what acceleration will be caused by the same force in a body of mass 5 kg. If you apply same amount of force, what will be acceleration for 5 kg? So here first we have to find the force. F equals to m into a. M equals to 0.5. It is 10 acceleration. So it is 5 Newton. That much of force is applied. Okay. So as 5 Newton force is applied, how much acceleration will be 5 kg? So now mass m equals to 5 kg, F equals to 5 Newton, because same force is applied here, same force, so F equals to 5 Newton, and then acceleration will be F by m. Okay. So F equals to 5, this is 5, so it is 1 meter per second square. Very easy. Okay, so very easy numerical is there. Question number 13. It will not take much time to complete. Now we'll go for the last numerical. Okay, and then it will be over. Last numerical we will do. If it is done, then it will be over. Let's see. It is told, question number 14. A car is moving with a uniform velocity 30 meter per second. So as car is moving with uniform velocity, so we can say that initial velocity u is equals to 30 meter per second. Simple thing. Uniformly moving means it is its initial velocity. Next question, it is stopped in 2 seconds by applying a force of 1500 Newton. So stopped, t equals to 2 seconds, and force F equals to how much? 1500 Newton. Okay, very good. through brakes. So as it is torque, so final velocity v should be 0. Clear? Now calculate the change in momentum of the car. Wow. Change in momentum. So change in momentum means final momentum minus initial momentum. So here, as the final momentum is less, it's 0, and initial momentum it will be more. Okay, so if we want to do it, so final momentum will be mv minus mu. Okay, that will be change in momentum, that is del p, or we can write m into v minus u, but here the value of v is less. Whatever, we will not bother about that. We know one thing. What is that? We know that force equals to m into a. As here no mass is there, so how we can able to find the momentum? So we will take help from this equation. So it is m into v minus u by t. That is the equation of force. And if I am talking about m into v minus u, that should be f into t. Right? So if I put the value here, because we want to find to m into v minus u, so value of force is 1500. Okay, but we will write here minus 1500. Now you may ask, sir, why it is minus? Because we just want to stop the car. That means we are applying the force in opposite direction. In which direction the car is moving? Okay, in which direction the car is moving, we are applying force in opposite direction. So we can have to put that it is minus 1500. Time t equals to 2, so minus 3000 Newton. So if you want to take only the magnitude, so you have to write here m into u minus v is equals to 3000 Newton. Why u minus v? Because here u is greater than v. U is greater than v. That's why I have made the change. And if you take this one, this will give a negative value. Why? Because v is smaller, v is 0 and u is 30. And for that reason only we have taken like this way. Okay. Talking about the next one. The retardation produced by the car. Retardation produced by the car. I think it is the easiest question among all the question here. We know for retardation v is equals to u minus at. As for retardation we are talking about, v is equals to u minus at, negative sign. So from here we can write that a equals to u minus v by t. What is the value of u? 30. Value of v 0. Time t 2. So it is 15 meter per second square. It is 15 meter per second square. Now the next question, the mass of the car. Easiest one. Mass of car. So we know F equals to m into a. Okay. M equals to F by a. Value of F, we have seen value of F is given to you. How much? 1500. So 1500. Value of A 15. So it is 100 kg. So the answer will be 100 kg. That is the mass of the car. It is the mass of the car. Okay. So if you practice the another numericals by using that equation, I think you can able to do it. Okay. Thank you.